Hello everybody. It's been a minute. And by a minute, I mean I think it's been maybe since January since I've last posted something on my YouTube channel. And that's basically because that was the last time I had a moment to myself to pause and breathe and have some free time to myself to sit down and put together some sillies for you guys. So, in lieu of that, I think it would be good to just inform you about what I have been doing instead with my free time. Notably that I just haven't had a lot of free time in the first place because of this wonderful institution known as a university where people like myself who hate themselves get degrees in STEMs because they feel like they can have some sort of meaningful impact in the world. I say this sarcastically, obviously. I wouldn't be doing this if I didn't love it. Now, in comparison to what I usually upload on YouTube, which deals with books and kind of analyses of written works and things of that order, I am in a STEM major currently. I'm entering my 4th year at college, which is kind of crazy to think about now because I still feel like I'm 12, mentally speaking, that is. But boy howdy, does it just take up your time. I have no other words for it. It just takes up a lot of your time. Last semester, it wasn't too bad. I actually had more free time, I think, on my hands, but I just decided to spend more time with my classes, and that helped me. I had 3 classes, I think, really last semester. I didn't have biology. That was last spring. I had biology. What did I have last semester? I don't know. I'll go look it up and I'll list it right here. I'll list what classes I had last semester, and then this current semester, which currently ended, I had Calculus 3, Linear Algebra, Digital Electronics, and then an Intro to Programming course. And I figured, why not I just break some of these down for you guys? Just kind of tell you how the year went, how the vibes were, how I'm feeling. Yeah. So I think the best way to talk about these things is going from most enjoyable to least enjoyable. And it's kind of a short little tier list, I know, but I think the gaps are wide enough in between them that I can make a distinction in how much I enjoyed them. So please enjoy me as I fumble over my words for the next few minutes trying to piece together what I just experienced this past 5 months of my life. Now, first on the docket is linear algebra. I think, in my opinion, that was the class that I enjoyed the most. Why? I feel like it's because I learned the most from it, and it's because I remember most of it off the top of my head. If I can remember things that I learned in a class off the top of my head, then I think I can say that I definitely enjoyed the class. I can also say about some of the other classes that I enjoyed them, but I couldn't tell you much off the top of my head about some more of the intricate elements of it, right? If I thought about it, maybe I could. But besides the point, linear algebra. What is linear algebra? It is exactly what it sounds like. It is algebra, but for linear equations, but more specifically systems of linear equations. It's a lot more complicated than just, oh, here's a linear equation with an x variable in it, go solve for x. You do that, but you can take that concept and then you can expand it to be so much more bigger and so much more complex. And moreover, you can use these systems, i.e. matrices or linear transformations and all this other fun stuff, which I'm going to list here because it's 10:30 at night and I'm basically asleep at this point in time of the night. I know I'm a grandpa. I need to put on my pajamas and go to bed like a normal person does when they're tired. But yeah, you can use linear algebra in technology. Take for instance the Google PageRank system. What you use is a bunch of logic webs, and then You can determine which website is going to show up at the top of the search engine based off of how many other websites are referencing it and how many people are on it. And that just scrapes the surface. Or you can use it to model filters on pictures, on like the stuff you use on your phone or on Instagram or TikTok or whatever. That's all linear algebra. That's all this stuff. That's all these wacky matrix transformations. That's all these similarity calculations. Here's your change of basis. There's your whole bunch of other things. I'm just going to throw them on here. That's all linear algebra. That's all math. That's in your phone. Think about it. But you know what else is in your phone? Coding. And that's another thing I tried to learn this semester. And that was programming, but specifically with Python. This one's number 2 because I like the idea of learning how to code, but for some reason for me, the learning curve was very, very steep. After I got to definitions, my brain just decided that it did not really want to know how to type code, right? Like, obviously I can do it. I passed the class, praise be to God, but holy guacamole, that was hard. I sat down, I took so many notes. I don't know how you're supposed to take notes for a computer science class. And I probably should have done more reading on that, other than just like copying the code. We got the definitions. That was kind of hard to like wrap my brain around because for some reason I couldn't like get my head around how arguments and how calls worked. For some reason that just took forever for me to like click. I understand that now, but when you're learning it, it's just kind of a lot to take in. I think one other thing about like the learning curve with coding is its legibility, because our brain, right, it likes to read things in chunks. That's why we're able to read words the way we do, and it's why we're able to output large bricks of information and like books and stuff. That's just the way we do things. And for some reason, my brain sees a bunch of code like that. The first thing it tries to do is try and like break it down to just one big old chunk and then read it like a normal paragraph. And I don't know why my brain never got over that, but I had to make myself read it like it needed to be read. That was another big learning curve. Other than that, and the painstaking labs and errors and trials and errors that took over the course of those labs while I was trying to figure them out, I thought it was pretty cool, because when you learn programming, you can do so much with that in terms of not only as a career, but in just simple applications in technology, you know? That's something that really anybody, I think, needs to learn, and it's something I need to hone myself. I'm probably going to go back this summer and look over some of that, and I don't know, do a little bit of Memo on my phone. It's just been sitting there idly, waiting for me to use it, but, you know, something to consider. Next on the list, and this is also really enjoyable, was digital electronics. What the heck is digital electronics, you might ask? Well, it's basically like an introduction to the logic systems that run computer programming and basic software and stuff. The kind we did was like HTML programming based. I think what made digital electronics for me really fun was trying to build the different circuits. So like in digital electronics, you've got different kinds of circuits. You've got synchronous circuits, and then you've got the other kind, and I don't know why I can't remember it, but it's literally just input dependent. Like you flip on this input and turn the other one off. You're gonna run it through a logic system, and then you're gonna get this output. I think the coolest things that you can make with those are like adders. I think that's really cool. Memory, building a little computer at the end that literally stores memory. That was, I think, really cool. Using a bunch of flip-flops and different logic gates for that. I thought that was really cool. But oh my god, the wiring, that kind of sucks. Because when you're doing like stuff on a breadboard, and your wire is off just barely, like if you put it in the wrong pin on the chip, so your chip has a bunch of pins on it and they're all assigned to different gates. If you don't like ground it right, you don't take your ground pin and you don't connect it to low, or if you connect like some wire into the adjacent one when you need to go into the other one, it screws your whole system up. And when you've got like a rat's nest of wires just sitting over you like that, that's kind of tricky to like try and troubleshoot. It's doable, a little tricky, but you know, I still think it's fun nonetheless. I enjoyed it. I probably should have taken the next course that goes along with it, given that I did enjoy it this much, but I think I'm kind of glad that I chose the current courses that I do have. But I'll talk about that at the end of the video in terms of what's next for me in my next semester, and kind of talking about how if I do make any more YouTube content, it's definitely just going to be over the summer because, my God, I'm not going to have any time. Anyway, last but not least, we have Calculus 3. Now, Calculus 3, for those of you who haven't taken it yet, or those of you who haven't taken like any sort of calculus at all because you're not really in a STEM field that would require you to take and know how to use calculus. Calculus 3 specifically is an amalgamation of regular calculus, which is just, I'm going to say derivative calculus, which is the study of derivatives, and this is what a derivative looks like, and this is what a derivative is. And then you have integral calculus. This is an integral. This is what an integral does. And there's a bunch of things you can use with integration and derivation and mixes of the two. A really good example from Calculus 3, if you want, is something called a line integral. And a line integral is used to calculate the amount well, you can use it to find the amount of work done on a curve or on a surface. That's a surface integral, but same concept. But you can find the amount of work done by some sort of field of vectors that is passing through or pushing onto that surface and or curve. But I'm going to say curve because I'm talking about line integrals, and that's as far as we got in the book. But I did read ahead a little bit on surface integrals. Those things are terrible to try and solve, but besides the point, yeah, really cool stuff. And then if you want to like go by extension and go like really far, you can do things like Biot-Savart or some Maxwell's equations. Use the del operator, which is just basically a gradient by itself, and you can use it to cross it or dot things with, and you can derive other things. The reason why I have this listed last, despite myself being a physics major, is that I've taken other calculus courses, enjoyed those calculus courses, learned more in those calculus courses, which was at the time about as equally difficult in terms of content, but I feel like I learned more. And the separator between those calculus classes and the current classes that I'm talking about this semester as well, it was just like the number of examples we did, right? My previous classes, we wouldn't spend too much time on the proof. We would talk about it conceptually for a little bit, get a general idea, write maybe the general formula for it, maybe derive it if we have the time, and then we would spend most of the rest of the time working hard examples of what we were talking about. That did not happen as much in Calculus 3. I do believe it is important to focus on the derivation and the tie-in to the conceptual understanding of how we have these sort of concepts in Calculus 3. I do. However, when you are kind of thrown that much material at you, and your brain is trying to work out how the heck do I even derive something for a problem I don't know what I'm trying to solve for, that becomes a little bit tricky. The weight to actually learn how to apply those theorems definitely fell more on my shoulders. And I'm not saying that teachers should hold your hand through it the whole way, but it was learning the problem-solving processes to solving these kinds of problems that we were being affronted with. We were kind of handed a wrench without ever being told what a wrench does in action, but what a wrench does in concept, if that makes sense. And some people, they learn that way, and that's perfectly fine. Issue is that not a soul really learned that way in our class. And it was not pretty, and it was kind of awkward most of the semester. There were some good times, though. I will admit it. I mean, I had some concepts I really enjoyed learning about. I'm bad at it, but I think vector fields and those kinds of equations are really cool to like try and piece together. And what they describe is probably the most elegant explanation of mathematics that I've ever seen. Like in terms of like you taking those equations and then modeling them. It's really cool. Like you can do a lot of stuff. That's the only reason why Calculus 3 is all the way down here. It was just trying to teach yourself how to do math is a little bit difficult without seeing a hint of how it is in action. If I do make videos this summer, and I release them in a row, expect them to be kind of more on the educational end of things. I might do a series on physics or on math for that reason. I think that would be a fun thing to do, trying to explore. I am going to release other videos that pertain to content like I have done in the past still, in regards to like books and reading and analyses of that order, because those are fun to do always. If I can, I'm still gonna try and get that one really long project I said I would do like 2 years ago. If I can get that out, I hope you guys enjoy that and what other content I make. But if I would like to do more oriented content that is related to my field. Expect more mathy content. Maybe some goofy math videos even. I just want to talk about stuff, and I like sharing it with you guys. End of story. I love you all. I hope you have a wonderful afternoon, and if you're studying, you can get through it, okay? You're smart, intelligent, and capable of everything you put your mind to, and you can do it. Just go on to like a bow in Tokyo and put on a Pomodoro, make yourself some coffee, and just go at it. Don't let that course kick you in the butt. You kick it in its butt. Peace.